You think your personality is yours, your introversion or extroversion, your anxiety or your calm, your tendency to trust or to doubt, the way you react under pressure. You built these traits through experience, you tell yourself, through choice, through who you decided to become. But the science says a significant part of who you are was written before you took your first breath, before you had a single experience, before you made a single choice. And some of it was written by people who lived before you were born. The field that studies this is called epigenetics. For most of the 20th century, the dominant model of genetics was straightforward. You inherit a fixed set of genes from your parents. Those genes determine certain traits. The environment can influence behavior, but it cannot change the genes themselves. That model is incomplete. Epigenetics is the study of changes in gene expression, not changes to the DNA sequence itself, but changes to how genes are switched on or off. And these changes can be caused by experience, by environment, by stress, by trauma, and they can be passed down. The most well-documented human case comes from a historical event known as the Dutch Hunger Winter. In the winter of 1944 to 1945, the Nazi occupation of the Netherlands caused a catastrophic famine. Approximately 22,000 people died. Those who survived faced months of severe starvation. Among the survivors were thousands of pregnant women. Decades later, researchers began studying the children born to mothers who were pregnant during the famine. What they found was striking. These children, now adults, showed significantly higher rates of obesity, diabetes, cardiovascular disease, and mental health disorders compared to people born just before or after the famine period. Their mothers had starved, and their bodies had been permanently altered by an experience they never personally lived through. But it goes further than physical health. Research on stress and epigenetics has shown that traumatic experiences can alter the expression of genes related to the stress response system, specifically the HPA axis, which governs how the body reacts to threat and fear. A study published in Biological Psychiatry examined Holocaust survivors and their children. Researchers found that both the survivors and their adult children showed altered cortisol levels and stress hormone regulation, even though the children had never experienced the Holocaust themselves. The children inherited a biological stress response shaped by events that happened before they were born. Their nervous systems were calibrated by history. This is not limited to catastrophic historical events. Research on mice has demonstrated that fear responses can be transmitted across generations through epigenetic mechanisms. In a study at Emory University, mice were conditioned to fear the smell of cherry blossoms through mild electric shocks. Their offspring, who had never encountered the smell or the shock, showed heightened sensitivity and anxiety responses to the same scent. The fear had been inherited, not as a memory, as a biological sensitivity. The grandchildren of the original mice showed the same response. 3 generations, 1 experience, passed down without a single word, without a single shared moment. Now bring this back to you. The anxiety you feel in certain situations. The way your body tenses before conflict. the hypervigilance that never fully turns off, the difficulty trusting people you have no logical reason to distrust. Some of this is your experience. Some of it is your history. But some of it may be older than you are. Researchers are careful to note that epigenetic inheritance in humans is still an active area of investigation. The mechanisms are complex and not fully understood. But the evidence from multiple independent studies points in the same direction. What happened to the people before you left a biological trace in you. There is a second layer to this that operates even before birth, within the womb itself. Research on prenatal stress has consistently shown that a mother's stress levels during pregnancy directly affect the developing brain of the fetus. High cortisol levels in a pregnant mother cross the placental barrier and influence the development of the fetal HPA axis, the same stress regulation system we discussed earlier. Children born to mothers who experienced high stress during pregnancy show measurable differences in stress reactivity, emotional regulation, and risk for anxiety disorders, differences that persist into adulthood. You were being shaped by the emotional environment around you before you had the capacity to experience it consciously. So what do you do with this? The first thing is to hold your personality more loosely. The traits you struggle with most, the anxiety, the reactivity, the patterns that feel impossible to change, may not be failures of character. They may be inherited biological settings that made sense in another context, in another generation, under circumstances you never personally experienced. This does not remove your responsibility for how you act, but it changes the relationship you have with yourself. You are not broken. You may be calibrated for a world that no longer exists. The second thing is to recognize that epigenetic changes can also go in the other direction. Positive environments, consistent safety, and reduced chronic stress can alter gene expression too. The inheritance is not a life sentence, it is a starting point. You did not choose your genes. You did not choose the womb you developed in. You did not choose the stress your grandmother carried, or the fear your grandfather learned to survive. But all of it is in you, not as destiny, as a starting configuration. What you do with that configuration, the environments you seek, the patterns you examine, the stress you reduce, that is where your agency actually lives. You are not just yourself, you are everyone who